Assalamualaikum warahmatullahi wabarakatuh. My name is Hana Dirisha binti Alfi, and I will be presenting for the Group 5 Experiment 3 Vapor Compression Refrigerator. So for the group members, it includes me, Hana Dirisha binti Alfi, Nurul Azwa binti Kamal, Muhammad Amir Ashraf bin Muhammad Nazali, and Syafiq Hidayat bin Johan. So for the introduction, the objective of this experiment is to study the performance of the vapor compression refrigeration system and to find its coefficient of performance. The vapor compression refrigeration system is widely used for cooling and refrigeration purposes in domestic, commercial, and industrial fields. This experiment will analyze the thermodynamic performance of the system by studying pressure, temperature, and energy transfer at different points of the cycle. The vapor compression refrigeration cycle works by circulating the refrigerant and through the four major components: compressor, condenser, expansion valve, and evaporator. During its flow, the refrigerant undergoes changes in state by absorbing heat at the evaporator and rejecting heat at the condenser. In the present experiment, the COP is determined by the ratio of the cooling effect produced in the evaporator to the work input supplied to the compressor. Theoretical and experimental values of COP are compared to comment on the efficiency of the system and deviation caused by pressure drops, heat losses, and irreversibilities.
So this is the experimental setup for this experiment. So on the top right, there is evaporator pressure, evaporator water flow meter, watt meter, valve 2, evaporator and compressor. While on the left side, there is condenser pressure, condenser water flow meter, condenser, valve 1 and also main switch.
So I will be explaining about the methodology of the experiment. So the first step of the experiment is we have to open valve 1 and valve 2. And then the second step is we have to open the water pipe, and after that we have to set the water flow rate to the evaporator as 25. The next step is we have to switch on the main switch, and then after that we have to let the cooling system stable. We approximate the time for it to be stable is 10 minutes, so we set on the timer for 10 minutes before we proceed to the next step. And then after 10 minutes, step number 6 is record the readings for temperature 1, temperature 2, temperature 3, temperature 4, temperature 5, and temperature 6, and also temperature 7. And then we also take the reading for the pressure gauge of condenser and pressure gauge of the evaporator, and also the watt meter, the value of watt meter. Next step is we have to repeat the experiment by changing the flow rate of water to condenser between 25 to 40. We have to repeat the experiment 4 times so that we have 5 data of the value. And then the next step is switch off the main switch after we finish repeating the experiment 4 times, and then turn off the water pipe after 1 minute. And lastly, we have to close the valve 1 and valve 2.
These are the results that we obtained from the experiment with different flow rate to the condenser. We measure the condenser gauge pressure, evaporator gauge pressure, compressor power input, and T1 until T7. We also calculate the rate of heat transfer at evaporator and condenser and coefficient of performance COP. The calculation will be shown in the discussion.
So the discussion that we can get from this experiment. So the first question asks us on how to calculate the rate of heat transfer that occurs in the evaporator and the condenser for the 5 tests run and discuss the result. So to calculate the value of rate heat transfer, we can use this formula, which is Q evaporator equals to M, which is mass flow rate of evaporator, times Cp, which is specific capacity of water, times T1 minus T2. And for Q for condenser is also the same, which is mass flow rate times specific capacity of water times T3 minus T4. And COP is Q evaporator over Q condenser minus Q evaporator. So in the first test, which at absolute compressor of 50 G per second, so the heat that we can get in the evaporator is equals to 0.3762 kilojoule per second or kilowatt. And Q is condenser is 0.209 kilojoule per second or kilowatt. And also the COP in the first test is negative 2.25. So the calculated value for 5 tests is as shown. It is found out that the rate of heat transfer at evaporator is higher than the condenser. This is because in the evaporator, heat is added to the liquid and change its state from liquid to vapor. Thus, more energy is required due to large separation of particles in a gas state. And in the condenser, heat is removed from the gas and change its state to liquid. And the second question asks us to explain the effects of changing the condenser flow rate of T1 to T7 to compressor power. Draw the graph and discuss the results obtained. So the graph shown is the graph of temperature readings at different points over time. So the explanation of this graph is in the vapor compressor refrigeration system, each component is crucial for effective cooling, as shown by the temperature readings at point T1 to T7. The evaporator, which are T1 and T5, absorb heat to cool the interior. T1 remains steady, indicating reliable cooling, while T5 shows a slight increase, likely where heat is first absorbed. The compressor, which are T6 and T7, boost the refrigerant's temperature and pressure. Both T6 and T7 rise sharply, especially T7, highlighting the heat generated by compression. In the condenser, which are T3 and T4, the refrigerant releases heat. T3 shows a slight increase as heat dissipates, while T4 remains stable, indicating effective cooling. The expansion valve, which is T2, lowers the refrigerant's pressure and temperature, preparing it for the next cooling phase. The small temperature drop in T2 reflects this process. Next, the graph shown the compressor power input against absolute condenser. So when the condenser flow rate decreases, the compressor power increases. The decrease in flow rate allows the refrigerant to lose heat more slowly. So more work to be done by the compressor to the refrigerant, leading to increase in power input.
So I will be explaining about the conclusion of this experiment. After we have done the experiment, we found out how does the vapor compression refrigeration system works and how does it transfer heat from the evaporator to the condenser. For the coefficient of performance, COP, when the flow rate is 50, the COP is negative 2.25. When the flow rate is 40, the COP is negative 1.7619. When it is 30, the flow rate, the COP is negative 1.54545. When it is 20, the COP is negative 1.4, and lastly, when the flow rate is 10, the COP is 2.53846. So from this result that we obtain, we can see that the COP is inversely proportional to the flow rate, which means when the COP increases, the flow rate decreases. The compression power also increases when the flow rate is increased. There might be some error that we made during this experiment, which contributes to the accuracy of the results that we obtain. One of the error that we could have made is the eye position while reading the value of the thermometer or the temperature. It might not be directly to the value, so that might disturb the accuracy of this experiment result.
Assalamualaikum, my name is Hanan Jirsha and I will be presenting about safety procedures. So for the safety procedure, check the pressure gauge regularly to ensure pressures do not exceed safe operating limits. Secondly, inspect hoses and fittings for damage or wear before starting the experiment so that it doesn't cause any leaks. Slowly open valves to avoid sudden pressure surges because it will cause explosion. That's all.